Well, hello again. My name is Jay with Server Matter and with CompuMatter, and this video is about ZFS, what the structure is, how snapshots are taken, and how you can, most importantly, in an emergency situation, get the results of those snapshots back under your control. Now, I am not an expert on ZFS, but I've certainly become a lot more knowledgeable over the last couple years as I've had to delve deeper and deeper into that world to protect our own servers. We use it on our server personally, we use it on our client server, and we use it on the server model that we expect to be selling an awful lot of. So let's touch on the structure first. And the main purpose of this video, to be clear, is for our future server administrators so that we can refer to this as a way to get our head around exactly what's happening with ZFS in our own environment, and by proxy, we hope that it'll help you. So let me minimize myself and get into it. So if you type the command ZFS list, as I have done here, okay, make these a little bit bigger. So we've got ZFS list, and you see we've got name. Let's look at the left-hand side, B pool, data pool. As we work our way down, our pool, okay, and that's it. We've got 3 different pools, and within those pools is contained all what are called data sets. Data sets are simply directories on your server that you give a name to. In this case, we're going to mount it to, you can see over here, it's SM data, client configs. The name of the actual data set is this entire structure, and so this mounts to that, and this mounts to that, and so on down the line. And data sets are important because if you ever want to restore a snapshot, now within these directories, let's take some of these directories on the right-hand side. My parent directory is SM data, and within that I've got a bunch of other individual directories. I might create directories within those directories on the server, and I might create 100 subdirectories of those directories. When it comes time to restoring snapshots, it's the parent data set that you're going to be taking a close look at and drilling down from there. But let me go into this a little bit deeper. I just wanted to show you that structure. So we've got basically the ZFS environment, we have the pools, and we have the data sets within the pools. And we're going to just take a look at the Z pool list, just the Z pools, instead of looking at that whole complex setup. And it shows us those 3 different pools, how much data they have in them right now, and what's their health. Okay, so that gives us the Z pool list. Let's take a look at just the data sets that have the word data pool in them. Let's say that's all I want to look at. And that simplifies things for it, makes it a little bit more easily digestible, seeing what we saw just a minute ago. Those are the data sets. That's the size of the data set on the right-hand side. That's the directory that it mounts to. It all starts to make sense. Okay, enough about data sets and pools and that kind of stuff for just a little bit. We're going to talk about snapshots. So when you install this program called ZFS Auto Snapshot, you install a ZFS, you've got that running, but you want to get snapshots that are taken periodically. And so most people turn to ZFS Auto Snapshot. It's not the only solution, but it's probably the most well-known. And when you install that, it sets up Cron, which creates a daily, weekly, monthly, hourly, and even a 15-minute snapshot, and in a default scheduling period, which I believe in my case was the last 4 15-minute periods every hour, and it keeps, I think, a day's worth of the hourly, and every day, and keeps 31 days worth of those, and every month. And I think it keeps 1 month worth of those, or at least that's what our setup was. And they're spread out in the Cron subdirectories of daily, weeklies, and so on. And frankly, they were out of sight, out of mind, and I had an emergency situation. I had to recover some data from yesterday on a snapshot that was done yesterday. And I thought our snapshots were being done every 15 minutes for at least the last day. I was very surprised to learn that it was only the last 4 15 minutes. The problem with that is the data is not very granular, especially if you've got a situation where people are dealing with large volumes of changing data. 45 minutes worth of data entry can be a very big deal. So we want to make it more granular than that. And we've decided to get rid of the Cron and all those daily, weekly, monthly setups and enter it all into a single cron. And this is what that looks like. We're going to go ahead and edit our ZFS Auto Snapshots, which is contained in etc. cron D, one file that does it all. Now that red and yellow background is probably going to be a little difficult to digest, so let me bring over a black and white one. So at the beginning of the cron, we tell the system what to use. We set the path to that, and that allows us to just type in ZFS Auto Snapshot right there without pathing to it. It is long enough as it is. We're going to try to abbreviate it. The local time, now I'm just going to look at one of these, the 15-minute for now. This says every 15 minutes it's going to run as root the command flock var run ZFS Auto Snapshot log. What does that mean? Well, flock is a program that stops processes from tripping over each other. So if you've got multiple processes that do the same thing, the program called flock, which came pre-installed with Ubuntu servers, so you've probably got it if you've got a Linux distro. You put that command in front of your command for the snapshot, and that way if you have a 15-minute, a week, a month, an hour that happen to run all at the same time, it's going to ensure that one is done before it allows the other one to complete. Now, I don't quite frankly know if flock puts it in a queue or flock just forgets about it till the next one. So far I haven't experienced any problems with my cron since choosing this system and the ZFS snapshots, but if you find out otherwise, we'd be glad to hear from you in the comments. So we preface it with flock and we create a file called ZFS Auto Snapshot lock, which is the lock file that they look for to know if something's currently running. And then we run the actual bash script. And you notice the SH, which sets up the local time. This is important. ZFS by default gives you UTC time in its snapshots. And when it comes time to have to restore data from an emergency situation, and you're looking at UTC and they're saying it happened at 2 o'clock yesterday, and you're having to do the math to figure out which of these snapshots are the ones that you need to restore, and you certainly don't want to get it wrong. And sure, it's not rocket science, but it's an extra level of brain damage that's avoidable if when you take the snapshot, you do something like this. And so then, we've assigned a variable to local time, and then here we put a semicolon here, and here we're running the actual snapshot. We're telling it to record data in syslog, and we're giving it a label that says 15 minutes appended by the local time. Now they're still going to append their UTC time to that, but at least we've got that. And then keep 96 of them. So every 15 minutes, that's going to run. It tells the ZFS Auto Snapshot program that we're keeping 96 of them. So if it hits that number, it knows to start culling the crop. Same thing with daily, weekly, monthly, similar format. The only thing we're changing is the label and the increment time period that it runs. And these are set to, for instance, I got this one running 30 minutes after midnight. So at 12:30 in the morning, this is going to run, and the weekly runs at the 15-minute period. I'm trying to do something so that they don't trip over each other so much, and then the monthlies run at midnight once a month. And otherwise, and you can see we keep one per month, we keep 4 of the weeklies, we keep 15 of the dailies, and we want to keep a whole month of the 15-minute, a whole day of the 15-minute snapshots, so that we can respond a day later. I'm tempted to even jump that up to double that amount in 2 days worth of 15-minute snapshots, but I haven't made that decision yet. So that's how our cron jobs work. They just do what they do, and the magic happens. All right, let's go back over to our server and take a look at what's happening. Okay, the first thing I want to show you is the actual cron jobs executing in the system. So we've got a tail f var log syslog grep for cron, and that'll show you anything that's got a cron in there and what's running. We've got a lot of different things running, but the ones that I want to that stick out right here, here's one of them. This is, you can see that command, the flock, blah, 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 and onto the ZFS. And this one is a 15-minute local time. So that ran at 13:45 today. And so you can take a look. So if you want to just check on things and see how they're going. Okay, so I've just run the command ZFS list -t grep for 15 minutes. So this is, if I didn't put the greps on there, it would just give me every snapshot on the system. That means every Z pool, B pool, data pool, and everything within all of those pools. A lot of information, but if you want it, you can get it. But I'm going to grep for just those that are 15-minute snapshots, and I'm going to grep further yet and ask for only those that have the word data pool in them. And even that's a lot of 15-minute snapshots because we're doing it every hour of the day. So, and on every single data set within the data pool SM virtual environment. So you can see we've got a long list here. So let's isolate a little bit of that. Let's just take a look at these guys here. Okay, this is on the data set that is SM data, SM resources. And there is one snapshot, we had 0. That means those snapshots had 0 bytes in them. Nothing had changed between it and the previous change. I believe that's what it is. So this particular one, though, that snapshot recorded a 388 megabyte difference. So something was added, or many things were added that totaled 388 megs. That was added to the snapshot, and on the right-hand side, we see that the data set is now at 5.07 gigs. So that's what that's indicating. Now, on the next snapshot, we see 112K and a reduction. One second. Okay, glad I got that open. Anyway. So we see a reduction. We see a snapshot of only 112K. So something, a text file or something small is in there, 112K, nothing to it. And here we see the data set has dropped back in size to 4.69 gigabytes because that file was evidently removed or other files. And then the next snapshot, nothing changed. No data was added, no data was taken away. There's no difference in the size of the data set, and that goes on, and that will continue to go on until somebody drops a file, in this case in SM resources, and that changes again. So let's add a file to SM resources so you can see what that looks like. Okay, so we're looking at the SM resources directory on the server, which we know maps to the data set by the same name, and anything in there will be saved every 15 minutes if it changes. Or every hour or every day, depending on how long it sits there. Now, I'm going to create a directory called our test, and then we're going to go over to our Windows environment, which is linked to this via a shared directory. And we see here SM resources. We see our new directory called our test, and let me find a file to drop in there. Okay, I'm going to drop this zip file in there. It's got some size to it. Okay, that's done. We'll go ahead and move that out of the way. We should now be able to... Okay, so I've just added a large file to the SM resources data set. In fact, I created a directory called our test. I then added this file called CSP. You can see it's a 3.5 gigabyte file. So we're going to notice a big jump during snapshots for SM resources based on before this file was added and after it was added. Let's have a look at that. Okay, so I've got a list here of the 15-minute snapshots on the SM resources directory. So I can see here a difference, 5.07 gigs to 8.58 gigs. That's a clear, that's the point where I dropped a 3.5 gigabyte file into that folder. Bottom line is we can see it in the data set. So we know that it's there, we know that it's still there, and we're going to look at that file. Our test, We can see the files there. We can see the file size. Now we're going to remove that file. Okay, we can see that there's nothing in it. And now let's go through the process, because now we're at where a customer would be. They'd call, they'd say it's an emergency, our directory's gone. Can you restore our files from wherever, you know, in your environment, your backup, your ZFS, what have you. And we're going to log in, and this is what we're going to do. So first we're going to get a list of data sets, and then we're going to ask them, where was the file? Or where was the directory? Or maybe it's the entire directory. And then we're going to isolate that and get within it to get its data. And let me show you how we're going to do that. The magic here is every data set has a hidden directory in it called ZFS, and within that hidden directory is every single snapshot. So if we look at, it doesn't even show it to you, even with an LSLA for hidden files. But there it is, and we're in it. And if we do a directory, we can see that we've got a shares and a snapshot directory. And if we go in that, we can see all our snapshots. So we did the list, you know, just to show you the ZFS way of seeing all that stuff. But the fact is, all we needed to do is go into SM Data, SM Resources, the hidden directory CFS, and look at the snapshots that are there. And since that has the hourlies, the weeklies, and everything else, we will grep for just the 15 minutes. That shows us our various snapshots, but it doesn't show us which one the file size increased at. So in this case, we're going to want to restore from whatever snapshot we think is the time frame. So we've got this 2/25/14/23. That's when we forced a snapshot. So that should work out. So we're going to see what's inside of here. And we can see our directories. We see the directory called our test, and we see the file. So now all we've got to do, now that we know that that's there, we're going to copy that to the same folder. And we're not going to move it. Be very careful about that. Okay, so that's copying. Don't delete anything that is in the hidden ZFS directory. My experience on that has been catastrophic. I've only done it once, and after doing it, it seemed all things ZFS broke. And they broke in a very random way. And I think, it's been a few years, I think we ended up having to reformat, reinstall as a result of it. So if you're going to delete snapshots, do it the ZFS way. Okay, that's done. Let's get out of here. And do a directory. And as they say in England and in Massachusetts, and Bob's your uncle. There's the file. If we look back in the Windows area, we see the file is put back. And that is it. As I say, this is primarily designed for our future administrators. I think I may have said that. You know, because we'll forget. We don't need ZFS every day. It just does what it does. We don't look back at it. We've got documentation of the subject. But when you need to wrap your head around how are your snapshots done, you need to be able to retrace your steps. You need to know what's happening in the cron environment. You need to know what's expected from a snapshot when it's taken. You need to be able to verify that where the data lives and know how to copy it from that snapshot environment back into your system when that time comes. I hope you found this video to be of some value, and please consider subscribing to our channel, and you have a front row seat whenever we create another one. Thanks for watching. Bye-bye.